All right, this is a video about one solution, no solution, or all real numbers, or infinite solutions. Some mathematicians might say, although I really like all real numbers better than infinite solutions. But anyway, um, it goes back to this idea of a scale. So imagine you have this scale right here. It's balanced, and so you have to have the same amount on this side as you do on this side. Well, what could be the amount over here? Well, it could be 1. But if this side right here is 1, then what does this side have to be? 1. Or if this side was 7, this side would have to be 7 as well. So really, you could plug in anything into either one of these boxes as long as this box was the same value as this box. And that's what we call all real numbers being the solution. Really, you could name any number and that would be a solution. If you look down here, you've got a box right here that says 1 already and a box right here that says 3. And let's just assume that this box that's blank is the same value of this box that's blank. Well, what that means is that there's no way that you could ever balance these, because let's say I plugged in any old number. I'll just make up an easy number. Let's say it was 5, okay? So if I plugged in 5 right here, and we're saying that, remember, this has to be the same value as this. Well, that means this also has to be 5. And now all of a sudden you've got 8 on the right side and 6 on the left. And so it's not going to be balanced. There's always going to be 2 more on this right side since it started out with 3 and this left side started out with 1. So there'd be no solution here. And as you start to do these and get better at them, you can start doing them with variables. So if you look at a problem like this, first of all, I would take this -3 and this +12, combine them, and I'd call that 9. So let's rewrite this to say 4g plus 9. I can tell right away that this is going to have one solution, and the reason for that is I have a different amount of g's. You see over here I have the coefficient 8, and on the other side of the equal sign I have the coefficient 4. So I can take these 4g's out of here and move them to the other side of the equal sign, and I'm still left with some g's. I'm still left with some numbers here. So remember, the goal is to find g, and so there'll be a number that makes sense for g. I think it will be, it'll actually be 0, because if I take 9 from both sides, you're left with 0 on the right side of the equal sign, 9 minus 9. And so 4 times some number has to equal 0. Well, that number has to be a 0, because otherwise you can't get the product to be 0. So we divide by 4 there. G would equal 0. So that would be an example of one solution. Let's take a look at another one. This one right here. This is a little bit more intuitive. You can do it with your hands tied behind your back. You see how I have 5 x's here and 5 x's here? If you think about it as like slope-intercept form, it means the slopes are really the same. The only thing that's different is the y-intercepts. And so these things are never going to meet each other, these two, if we look at them as like lines. But let me just do it out for you. If I take 5x on this side, all I'm left with on the left side is 1. And I would also have to take 5x on the right side, because whatever you do to one side of an equal sign, in order for it to still be balanced, you do it to the other side of the equal sign. So these also cancel out. So now you're left with a statement that says 1 is the same as, I treat that equal sign as the same as, so 1 is the same as -2. And that just plain doesn't make sense. 1 isn't the same as -2. Come on. So there would be no solution right here that would apply for this one. Nothing x can be will make it true. And then this last one, you'd have to use the distributive property. So let's get this to say -2x plus 8. Right? And it's plus because you're distributing a negative over here to this negative. So negative times negative makes it positive. And then over here, 1 minus 3x, 1x minus 3x. Well, that's -2x. And so you can see right here, this reminds me of, I'm going to pull back this idea. I've got the same thing on the left side and the right side of the balance. And in the equation, it's the same idea. I've got the same thing on both sides of the equation. So I could plug in anything for x. All real numbers will work there.